Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on quantum physics from March 2022, paper 4, variant 2. In this question, we will discuss de Broglie wavelength, electron diffraction, and wave nature of electron. We will discuss when electron behave as a wave and when electron behaves as a particle. So these important concepts we will discuss today by solving past paper questions. For question number 8, part A, we need to state the formula for the de Broglie wavelength of a moving particle. We need to state the meaning of any other symbol used, means other than lambda. So if we write down the formula for de Broglie wavelength, lambda is equal to h over p. P is the momentum. You can also write down this one h over m. V. For example, if you write down h over p, then we have to state what is h. So h is Planck constant. So you have to write down h is Planck constant. So simply we can say h is Planck constant. And for p, p is momentum of moving particle. So we can say p is momentum of moving particle. So p is momentum of moving particle. So simply we can write down p is momentum of moving particle. You can also write down momentum of moving particle if you have written mv. So you can say mv is momentum of moving particle. So you can also write down, you can say momentum of particle, momentum of moving particle. You can also explain, you can say m is mass of particle. You can say m is mass of particle and v is speed of particle. So you can also explain it this way. So you can say v is speed of particle, or you can say is velocity of particle. So speed, or you can say is velocity of moving particle. So this is how you can answer this question. This question has 2 marks. The first mark is M mark. So you will get first mark if you have written this formula. And the second mark is answer mark. You will get if you have explained the symbols other than lambda. So second mark is answer mark. But if you didn't write this formula or your formula is wrong, you will get 0 m. Then even if you have written h is Planck constant and p is momentum of moving particle, you will get 0 mark. Answer mark you will not get. So you have to get m mark to get answer mark. If you have written this formula right, you will get 1 mark. If you didn't explain these symbols, you will get this 0 mark. Answer mark will be 0. But if here you got 0, even this is right, still you will get 0. So m marks are very important. You cannot get a mark if you can't get m mark. For part B, it is given to us electrons accelerate through a potential difference pass through a thin crystal and then are incident on a fluorescent screen. The pattern in figure 8.1 is observed on the fluorescent screen. Means electron pass through the crystal and we observe these circles. We observe this kind of pattern. For part B1, we need to state the name of the phenomenon shown by the electrons at the crystal. Electron behave as a wave and electron also behave as a particle, but it depends on conditions. So electrons behave as waves and electrons also behaves as particles, but it depends on the conditions. If you get this pattern, in this case electrons are not behaving as particles because electrons spread out. As electrons spread out, so this is telling us electrons are behaving in this case as waves, because particles do not spread out. If electron was behaving as a particle, so we should see electrons only here, but in this case we see electrons, they spread out, they form this pattern. As electrons spread out, so this phenomenon is diffraction. As electrons spread out in this case, so we can say this is electron diffraction. So simply we can say this phenomenon is electron diffraction. So simply we have to write down this phenomenon is electron diffraction because electrons spread out in this case. The second thing you can also understand, these are two crests and the distance between these two crests is equal to lambda. So it simply means that in this case electrons are behaving as wave. So we can say in this case electrons behave as wave. Now if we go to the second part, question is asking us to state what this phenomenon shows about the nature of electrons. Nature of electron we have already discussed. In this case electrons are behaving as waves. So simply we can say moving electrons behave as waves. So we can say moving electrons behave as waves. Electrons behave as waves. It depends on conditions, behave as waves. And if we need to find the value of the lambda, so lambda is equal to h over p, means the momentum of electron. If we have momentum of electron, we can calculate lambda. So h over mv. M is the mass of electron. So this is how we can answer this question. This question has 2 marks, means 1 mark for part 1. So this is B1 mark. And the second one is also B1 mark. For the third part, we need to suggest why the thin crystal causes the phenomenon in B1, means electron diffraction. Why we observe electron diffraction. Now we need to explain that one. First thing we need to understand, significant diffraction takes place. Significant diffraction. We need to understand condition for significant diffraction. Condition for significant diffraction is when gap size is almost equal to the lambda of the wave is equal to wavelength. Then we observe significant diffraction. So we have to write down the same thing here as well. In this case, gap size means spacing between atoms, or you can say atomic spacing. Spacing between atoms. So in this case, spacing between atoms, if that spacing is approximately equal to the wavelength of electron, then electron diffraction is possible. In this case, we observe electron diffraction. So it means that spacing between atoms is almost equal to wavelength of electron. So that's the reason we observe electron diffraction. So this is the point you need to write down. And this question has 1 mark. So this is our answer for this question. For part 4, it is given to us the electron is accelerated through a different potential difference. The new pattern observed on the screen is shown in figure 8.2. And this is our figure 8.1. So this is figure 8.1. And this is new figure 8.2. State and explain the change that has been made to the potential difference to create the pattern shown in figure 8.2. So we need to explain the change made to potential difference. Means the potential difference has been increased or potential difference has been decreased. So we have to state that. Then we have to explain that. Potential difference has been increased or potential difference has been decreased. This is what we need to state. And then we need to explain. State and explain. And this question has only 2 marks. 1 mark for stating, 1 mark for explaining. So let's try to observe the difference between these 2 patterns. If you look at new pattern, so this is wavelength here. So this is new pattern. We can say this is lambda new. If you look at old pattern, this is the wavelength. And we can say this is lambda old. Lambda old. In this case, it is very clear that lambda new is shorter than lambda old. If you look at de Broglie wavelength, in de Broglie wavelength equation, we have discussed that lambda is equal to h over p. If lambda has decreased, it means momentum has been increased. So first thing we can observe from here is that lambda has been decreased, so momentum of electron has been increased. Now we need to understand the relationship between kinetic energy and momentum. Kinetic energy is equal to momentum square divided by 2m. So if momentum of electron has been increased, it means kinetic energy of electron has been increased as well. And in this case, kinetic energy is given by electrical energy, So we can say this is over electrical energy. And electrical energy is equal to Q times delta V. In this case, kinetic energy has been increased, so it means we have to supply more kinetic energy to electron. Electrical energy has been increased, but the charge of electron does not change, so it means the potential difference has to be increased. So that's all what we have to write down for the answer of this question. So we will say in this case, accelerating potential difference has been increased because momentum of particle means momentum of electron has been increased because its wavelength has been decreased. That's all what we need to write down. Let me show you the answer, how you can write down answer for this question. This is how you can write down answer. So the first thing you need to state. So simply you can state in this case, this is the statement. Accelerating potential difference has been increased. And then you need to explain this one. So you will say wavelength has been decreased, so momentum of electron has been increased. Simply you can say electron has greater momentum. The first mark is M mark, means this explanation. So you have to explain in a right way. If you have explained in a right way, then you will also get the answer mark. If your explanation is wrong, even you have written potential difference has been increased, you will get 0 mark. So if you got 0 mark here, M0, this also will be 0. Even you have written potential difference has been increased. So your statement has to be right and your explanation has to be right. Then you will get 2 marks. But if your statement is right, but your explanation is wrong, you will get 0 mark.